Hello everyone. In the last video lecture series, we have discussed about the size reduction operations, the various forces associated with the size reduction operations and the different laws such as Rittinger's law, Hicks law and Bond's law. In today's fourth video lecture series, we are going to discuss about the size reduction equipments. We are going to use the concepts of size reduction operations in the size reduction equipments. Size reduction equipments. The size reduction equipments are classified based on three parameters. The first one is the mode of operation, the second one is the method of application of forces, and the third one is the size of the feed and products. The first one, based on mode of operation. There are two modes of operations, batch operated and continuous operated. In the batch operated equipments, the equipments are charged first, and then the size reduction operation takes place and the products are removed. In continuous operation, the equipments are charged continuously and then the products are removed continuously. The second parameter is the method of application of forces. In the last lecture, we have discussed the different forces such as compression, impact, attrition and shear. In impact, we have two types, that is impact on the surface and the impact between the particles. The impact denotes that more friable materials will be disintegrated first. So we are using it in the tumbling mills and ball mills. In the second one, compression. The compression is giving more forces on the particles and the particles will be disintegrated when the stress increases more than the elastic limit. The compressional forces are used in crushers and grinders. The next one is attritions used in the attrition mill, and the different other mechanical forces are the cryogenic crushing, the ultrasonic grinding, the thermal explosion, etc. Size of the feed and products. The sizes of the feed and products are classified as coarse particles, intermittent particles, the fine particles, ultra fine particles, and then the shear cutting machine. The ultra fine particles and fine particles are achieved through grinding process. The coarse and intermittent particle size reduction are achieved through the crusher machine. Now we move on to the selection of size reduction equipments. While selecting the size reduction equipments, we have to go through these criteria. The first one is the amount of capacity of the equipment. The second one is the equipment should not choke or plug. The equipment should operate economically and it should require less maintenance. The equipment should be more power efficient. The equipment should handle maximum input of the capacity. The next one is the equipment should be more abrasive resistant. The equipment should be having more versatility. The equipment should not choke or plug and then it should be easily operable. The equipment should have the replacement parts and it should be more easily available and it should be cheap. The equipment's fixed cost and the operational costs should be less. Now we move on to the tumbling or revolving mills. The tumbling mills are having the cylindrical shell which is revolving in slow manner. The cylindrical shell is charged to its half and then the tumbling motion is imparted on the feed particles. Then once the tumbling motion is completed, the disintegrated and the size reduced particles will be taken from the tumbling mills. The tumbling mills are of two types. First one is the batch operated, the second one is the continuous operated. In the batch operated tumbling mills, the tumbling mills are closed and then the tumbling motion is imparted on the particles which are fed to the tumbling mills and then the products are withdrawn. The next one is continuously operated tumbling mills. In the continuously operated tumbling mills, the feed particles and the withdrawing of the products are taken continuously. The tumbling motion is imparted when the cylindrical shell is run slowly. So that is the tumbling mill is acting based on the impact force. Now we are moving towards the ball mill. The ball mill is also working on the principle of impact force. The balls are used as the impacting medium towards the feed particles. The ball mill is also having a cylindrical slow rotating shell. Inside the slow rotating shell, the balls are used as less friable materials for creating impact on the more friable feed particles. The ball mills are charged once and the lid is closed. Like batch operated tumbling mills, it will be rotated for some time and then the size is reduced and the particles are taken out. Now we move on to the coarse crushers. As the name suggests, the crushers are used for size reducing the coarse particles from the mines or ores. The coarse crushers are gyratory crushers or jaw crushers. the coarse crushers are slowly operating and then reducing the coarse particles. The coarse crushers are using the compression force. The compressional forces are applied on the feed particles by using the two surfaces or plates, which one is moving or both are moving. The compressional forces creating stress on the particle, and then the strain is more than the elastic limit of the particle, then the strain breaks the particles into the desired shape. Thus, the compressional forces are creating the desired coarse particles to the desired shape of 150 mm to 250 mm. Now we move on to the two types of crushers, that is primary crusher and secondary crusher. The primary crusher is directly taking the bigger rocks as feed. That it reduces the primary rocks and then it reduces to the particle size as 150 to 250 mm, and then it is sending to the secondary crusher. The different crushers are jaw crushers, gyratory crushers and roll crushers. Now we move on to the jaw crusher. The jaw crusher is also known as primary crusher. The primary crusher is used in the mines to crush the ores. The primary crusher is crushing the ores by using the force of compression. The jaw crusher obtained its name as jaw crusher because it is having two plates, which is one is movable, the other is immovable, as looking like a human jaw. The jaw crusher plates are lined with abrasive resistant manganese steel alloy. Now we move on to the working of the jaw crusher. The jaw crusher, when the feed is introduced into the jaw crusher is moving, one plate is moving to and the other plate is fixed. When the movable plate is moving towards a fixed plate, the compressional forces are associated with the particles. The applied compressional forces creates the stress in the particles. When the stresses are created, the strain is also created. When the strain increases more than the elastic limit of the particles, the particle breaks. When the particles breaks, we get the desired products. The operation of the jaw crusher is intermittent in nature and we obtain the particles as discontinuous manner. Now we move on to the gyratory crusher. The gyratory crusher is the secondary crusher which is getting its feed from the primary crusher, jaw crusher. The coarse particles obtained from jaw crusher is fed into the gyratory crusher. The gyratory motion exhibited by the rotating spindle, which is present inside the eccentric conical casing with the throat at the bottom, is an example of this gyratory crusher which is shown in the figure. Now we move on to the working of the gyratory crusher. Inside the conical casing, the spindle is moving continuously, which is producing gyratory motion and the compressional force to the feed particles which is introduced from the top of the casing. So when the top of the casing is charged with the feed particles move towards the throat section where the spindle is rotating and it applies the compressional force. When the strain produced due to the stresses is exceeding its elastic limit, the forces breaking the particles so that we get a desired product. Now we move on to the difference between the jaw crusher and the gyratory crusher. The jaw crusher is having a reciprocating movement. The gyratory crusher is having a gyratory movement. The jaw crusher is having an intermittent movement where the products are received intermittently. The jaw crusher is releasing the products intermittently where the gyratory crusher is releasing the products continuously. The power requirement is more for the jaw crusher and the power requirement is less for the gyratory crusher. The loading of the motor is uneven for jaw crusher and the loading of the motor is even for gyratory crusher. The gyratory crusher is having more cost compared to the primary crusher. The primary crusher is having more feed size compared to the gyratory crusher. Now we move on to the advantages and disadvantages of the crushers. Advantages: stable working, full chamber feeding, easy handling of abrasives and starting. Disadvantages: massive structure, cannot crush the sticky and wet particles, cumbersome maintenance and operation. Now we move on to the next set of equipments, that is grinders. Grinders will be producing the fine and ultra fine particles. The grinders are obtaining the feed as the products of the crushers. The crusher's outlet is connected to the grinders. The coarse particles from the crushers will be grinded to fine and ultra fine particles inside the grinders. The grinders will be having an intermittent duty. The grinders having the intermittent capacity are having the products which are passing through the screen size of 40 mesh. The grinders having the intermittent capacity and the fine capacity are having the products which are passing through the size of 200 mesh. The different grinders are hammer mill, attrition mill and rollers and bowlers. The first one is the hammer mill. The hammer mill obtained its name from the hammer-like projections which are connected to the horizontal speed rotating shaft. The hammer mill is having a cylindrical immovable casing where inside which the horizontal speed rotating shaft with the hammer-like projections are kept in. It is connected to a motor so that the hammer and the shaft will be rotated to give the desired products. Now we move on to the working of hammer mill. The feed is entering from the top of the hammer mill which is impacted to the hammer mill, and the hammers will be striking the feed particles so that it will be broken and they will be thrown to a anvil plate where the particles will be rubbed and the fine particles are taken as products. Now we move on to the attrition mill. Attrition mill is a type of a grinder where the soft feed particles are grounded by the rubbing action between the two grooved surface of circular discs. The two circular discs will be rotating against each other so that the rubbing will be causing the size reduction of the feed particles. The attrition mill is classified into two types. The first one is a single runner attrition mill and the second one is the double runner attrition mill. In the single runner attrition mill, the particles will be ground between the one movable surface and the another flat immovable surface. In the double runner attrition mill, the two surfaces will be rotating against each other and the particles will be grounded and the size reduction takes place. The size reduction of the double runner will be more than the single runner attrition mill. Now we move on to the crushing rolls. In crushing rolls, two cylinders will be rotating against each other. The one cylinder will be moving to and fro with the help of the spring arrangement. The two cylinders will be pulling in the feed particles when it is introduced from the top, and the friction causes the size reduction between the two particles. The movement of the cylinder to and fro movement by one cylinder with the spring arrangement eliminates the wear between the two surfaces. Thus the size reduction is established. Let's come to the end of this session. I hope you all understood the concepts of size reduction equipment, the classification, the selection criteria for size reduction equipments, the different size reduction equipments such as tumbling mill, ball mill, crushers and grinders. In the next lecture, we are going to see about the solid-solid separation. Thank you.